super NDA at V1 and V2. Or even you can write combined nodal analysis at V1 and V2. How I am going to write this equation, everybody notice here. So first V1 I'll start. Combined, even if within the bracket you can write combined nodal analysis. Why I am saying combined word here? Because two nodes I am representing in the same equation. Two nodal analysis, two nodal points. See, V1 and V2 are two nodes here. I am going to put both the nodes in the same equation. So that is why I am naming here it as a combined nodal analysis. Okay, so I am writing for the first node. So it is going to be V1 minus 10 divided by 2 because the positive terminal is connected to V1. So I should subtract the 10. So V1 minus 10 divided by 2. This is for the first branch. For the second branch, it is going to be V1 divided by 4. As I said, it is correct. Now, what we are supposed to do means, in the super node analysis, for whichever branch you are having an issue or where your super node is existing, here is your super node is existing. Okay. Wherever you're having a super node or where you have a problem in writing a nodal equation, leave that particular branch. Now I'm leaving this third branch. I'm straight away jumping to your second node. What is second node? Here is your second node. For second node, how you will write the equation? V2 divided by 4 for the middle branch. And for the third branch, V2 divided by 4. And left side, this is super node branch. Even here, we can't write nodal equation. How? See, V2 plus 3 minus V1 whole divided by nothing is there. Here also we have issue with resistor. We don't have a resistor. So what I am doing here is I am combining the nodal equation for V1 and V2, but for whichever a super node branch is there, that particular term I am just excluding in the equation. You understand my point?
Yes, sir.
Yeah. So therefore, this is equals to 0. Okay. So this part alone, I just left it off. Now, can you simplify? LCM is 2. Tell me the equation. What you will get? 2V1 minus 20 plus V1 plus V1 plus V1 is equals to 0. So if I simplify this, what I'm going to get? 4 times 5 times V1. Then, no, this is V2. V2, V2. The equation is going to be 3 times V1, 2 times V2 is equals to 20. Equation 1. Am I correct?
Yes, sir.
Yeah. Now see, to find out two unknowns. Here two unknowns are V1 and V2. To find out two unknowns, we must require two equations. But now I have only one equation. So I need one more equation. One more equation, how I'm going to find out is, this is a point to be understood by everyone. This super node branch, I'm going to take it out. I'm going to take that super node branch, take super node branch from circuit. So I'm just going to take the super node separately. So V1 and V2 3 volts, correct?
Yes, sir.
Yeah. So this can be represented. This could be represented in another form. I'm going to represent this. Everyone notice here. So when I say V1, it is a voltage. I am just representing that voltage with the symbol V1. When I say V2 here, it is a node voltage, so it is represented with a symbol now. Voltage V2. Okay, 3 volt. See here ground is there, here ground is there. I can make it as a common ground now because it is commonly connected to your circuit. Now, just apply KVL to this circuit. Just apply KVL for the loop by KVL. Tell me the equation. Can someone help me? Just apply KVL for the loop. From where can I start?
V1 minus 3
No,
minus
yeah,
V
no, we follow starting sign. I said,
minus V1
yeah, minus V1
plus 3V plus
plus
3
3
plus V2
is equals to
equal
0.
to 0.
Very good. So this is going to be V1 minus V2 is equal to plus 3. Can I write? If 3 goes to the right hand side, it becomes minus. So if I multiply entire equation with negative, we'll get V1 minus V2 is equal to 3. I name it as equation. That's it. Now we are having two equations. So now we know how to solve two equations. You can go with elimination method. Solve equation 1 and 2. So equation 1 is 3V1 plus 2V2 equal to 20. This is V1 minus V2 equal to 3. So to cancel out any term, either you can multiply your equation 2 with 2 or even with 3. So I'm going to solve 1 and 2. How I'm going to solve, just see here. Solve equations 1 and 2. So from 1 implies 1, I'm just going to multiply with only 1. So no changes in equation 1. 3V1 plus 2V2 is equals to 20. From equation 2, I'm just going to multiply with 2. It is going to be 2V1 minus 2V2 is equals to 6. Am I right? Correct? Yeah. So now plus 2V2 minus 2V2, it is going to get cancelled. So 3V1, 2V1, it is going to be 5V1, 26. This implies V1 is nothing but 26 by 5. Can someone tell me how much 26 by 5?
5.2.
5.2. Okay, substitute V1 equation in equation 1 or equation 2. I am substituting in equation 2. Substitute V1 in equation 2. So V1 value is going to be, once again, I'll write, it's going to be 5.2 minus V2 is equal to 3. Therefore, V2 is equals to 5.2 minus 3. Am I right? Therefore, V2 equal to how much? How much I'll be getting? It's going to be 2.2. Correct?
Yes, sir.
So it's going to be 2.2 volts.